what is coordination complex, how coordination bond is formed. Then there is a different theory that can explain how these coordination complex can be explained. And there are a different type of a ligand that is attached, either it is anionic, cationic, or a neutral. And then the Warner theory, according to Warner theory, every coordination complex that follow the two type of a valency. First valency that corresponding to first valency that is corresponding to the oxidation number of the complex, and second that is corresponding
Recording in progress.
corresponding to coordination number of the complex, and primary valency that is corresponding to oxidation state of the complex. And oxidation state, and these complex, these type of a valency, these are the ionizable. The primary valency that is oxidation number, that is ionizable, and that is non-directional in nature. And the secondary valency that corresponding to the coordination number, and which is non-directional and non-ionizable. After that we will come to next, that is the common geometry in a coordination complex. There are different type of coordination geometry that is possible. First is due to the coordination number, whether it is in a coordination number of a 2, that is linear, 3 triangle, and the geometry, whether it is formed in which type of a geometry it is exist, either it is in form of an either it is in form of a linear, triangle, tetrahedral, square planar, or octahedral. Then like this complex silver ammoniated that exist in form of an uh, that exist in form of an I think it is in linear shape in which two ammonia that is coordinately bound within a silver metal, and the charge on this complex is +1. That's why it is exist in linear shape. Next is, if the common geometry of a complex which has coordination number is 4, and coordination number 4 means it is either in tetrahedral, or most common that is sp3, and second is d dsp2, means d orbital d orbital that is participating in bonding. But in case of a tetrahedral, it is an sp3 which having 4 ligand that is attached with a central metal atom. But in case of a square planar, the participation of an d orbital that make the shape different, and the 4 ligand that is attached with an central metal atom. That's why the main difference between both are 4 coordination number, but both having different geometry. In case of a tetrahedral, it is an sp3, but in case of a square planar, this is dsp2. Next is, if we take an example like in case of a tetrahedral, there are a different type of a complex. According to Warner theory, these first of all, if we take an example of a zinc tetraammoniated or iron tetrachloride, these exist in form of a tetrahedral. But if that nickel complex exists, it is exist in square planar. How we distinguish whether it is a square planar and whether this is tetrahedral? This theory, after that, after this theory, next theory come, that is VBT, valence band theory, that explain how these structure different as compared to tetrahedral and square planar. In this case it is a tetrahedral, but in this case it is square planar. Why this is happened, we will study later. Then next is, If coordination number is 6, it is exist in octahedral. Octahedral means there is an 6 ligand that is coordinately bound with a central metal atom, and that's why it is known as an octahedral. Octahedral means it is a 6 ligand that is coordinately bound with a central metal atom. And the geometry in this case, I think if we take an example of an 6 that cn ligand that is attached with an cobalt in it is a monodentate ligand, that's why it form an octahedral. But in case of a ethylene diamine, that is a bidentate ligand, and 3 means 3 into 2, that is total is 6. 6 that is coordinately bound to given geometry is octahedral. Then next concept comes is IUPAC nomenclature, but this is not in your syllabus. You have already studied the IUPAC nomenclature of an coordination complex. Coordination complex, but we will generalize how we nomenclature the coordination complex. First of all, there are different the cation and anion. These are the two type of a metal that exist in coordination complex. That's why the naming of a complex based upon the ligand that attached to central metal atom is on first priority, means alphabetically order. After that, metal ion that is named in last one we can say. After that, its oxidation state in an in Roman numerical follow the pattern. After that, no space in an complex name like the name of anionic ligand and with O, and if id speaks means that come fast, means if it is in different type of a suffix is used to nomenclature the coordination complex. If the ligand start with a bromide, if we take an example of a bromide, it is known as bromo, and chloride, chloro, cyanide, cyano, hydroxide, hydroxo, oxide, oxo, fluoride, fluoro, and the ligand carbonate, carbonato, and it is in exist in O. O means auto, and oxalato, sulfato, thianesto, and thiosulfato, and sulfato, sorry. And the neutral ligand that are usually named based upon the name that is exist in original form, like ethylene diamine. Water, in case of a water it is known as aqua, in case of a ammonia it is known as amine, and carbon monoxide that is known as carbonyl. And the IUPAC nomenclature of an whether it is exist in mono, di, tri, tetra, penta or hexa, with how much ligand that is attached with an central metal atom. If two ligand is attached, means it is di. If it is three ligand attached, tri. Four is tetra. Five is penta, and six ligand is attached is known as hexa in according to IUPAC nomenclature. Then if the ligand name contain the prefix like a bi, tri, tetra, penta, it is in form of a kiss, means that name is alternative prefix. Some ligand has some prefix, that's why the ligand is placed according to sequential order. And if a complex end with an 8, the name of a complex, like if we take an example of a transition metal complex, if we start from scandium means scandate, titanium, titanate, and chromium, that is chromate, vanadium, vanadate, and manganese, magnetate, and iron, ferrite. After that, cobalt in form of a cobaltate, and nickel, nickelate, and copper, cuprate, and zinc is exist in zincate. These are the normal IUPAC nomenclature of a transient metal that is attached in an coordination complex. If we take an example of an isomerization, if we count what is isomer, isomer means compound having compound having same composition or same empirical formula but different in its arrangement. Different in its arrangement means either it is exist in cis, trans or E type of a configuration or Z type of a configuration. Sorry, either it is exist in which type of an complex. That's why the isomer having same empirical formula or same composition but the arrangement of an attaching element or atom are different. Majorly it is divided into two categories. First is based upon the structure isomer, whether it is exist in which type of a structure is exist, and whether it is a second is stereoisomer, which having different stereochemistry. Stereochemistry, whether it is a it is exist in E form or Z form or cis form or trans form. That is the majorly it is divided into two categories. First is based upon structure, whether which type of a structure it is exist. Second is stereoisomer. First of all, if we come to structure isomers, isomer that having different bond means whether whether it is exist in form of an isomer that exists having a different bond means structure is different, means it is an axial or equatorial. If an axial bond are longer as compared to equatorial, that's why the structure isomer that based upon the which type of a ligand that is bounding with an coordination sphere. Coordination sphere means which type of a coordination sphere that form an isomer. Like if we take an example of an coordination sphere which having different structure. If we take an example of cobalt 5 ammoniated chloride and last one is attached with bromine. And if bromine is inside the sphere or bromine is outside the sphere, that the ligand attached here are same, the structure composition is same, but the arrangement of an bond in coordination sphere, bromine in one case bromine is outside the sphere, in second case chlorine is outside the sphere. That's why it has different structural composition, means the bond connectivity with the central metal atom is different as compared to another coordination complex. Next is if we add the as we add some uh, as we add this complex in any solvent means any water, any ammonia, then these the sorry, then the outer sphere ligand that is easily dissociated in the solution and that can easily give the coordination complex which has positive charge. And if second complex that is added in solution, any solution like a water or ammonia or any solvent, then it form an outer sphere ligand that attached with the matter is easily dissociated in the solution or any solvent. If we take an example, if you add some type of a solution like if we add water, ammonia or silver nitrate. In case of a silver nitrate, if you add silver nitrate in the solution, Then these complex, these exchange the outer sphere. Outer sphere means outer ligand that is exchangeable, means that bromine is easily exchanged with nitrate. That's why it forms that type of a cobalt ammoniated chlorine and ammoniated complex. And second one is silver bromide complex. But if we add second complex, that type, it is a it common that type of a ppt, that is yellow type of ppt. But if you add silver nitrate in this solution, then it form white color of AgCl. That type of a ppt is known as the outer sphere that is easily dissociated in the solution. That is the main thing in a coordination sphere. Next is structural isomer. Structural isomer, the linkage between the ligand is different, and the attachment of the ligand with the coordination metal is different as compared to another metal complex. Linkage means the linkage between the these are different, like whether oxygen first attach with that one or nitrogen first attach with that central metal atom. There are different type of a bonding exist, whether oxygen first attach or nitrogen first attached is the linkage isomer that exists. Linkage in case of a nitrate, like a N first directly attached to that cobalt, but in case of an ONO means oxygen that is directly connected with us that cobalt central metal atom, that exist in different type of an geometry. Second example, if we take in case of a SCN or NCS, means the composition of the complex, this one SCN and NCS, the composition of the coordination complex is similar, but the connectivity with the central metal atom is different as compared to initially coordination complex. In case of a, this one, it is connected with SCN, and in this case it is connected with nitrogen. This is all about the isomer. Actually, my health condition is not good. I will take extra class, because if any doubt, please raise your hand or otherwise write in chat box.
Recording stopped.
Otherwise, we will continue the class on tomorrow.